Welcome back. This is course 29 of the Code to Vibe Academy. In course 28, you built a complete feature end-to-end on the web app, a shoppable product catalog with a working cart, fetching, filtering, cart state, all wired up, all described, not hand-coded, and verified in Antigravity 2.0 with the built-in browser. Now we go deeper into something every real app depends on: data that persists, data that has structure, and data that holds together even when things get complicated. Here's the thing that most vibe coders skip too early. They let the agent just figure out the database, and it will, but figure it out is not a schema, right? A schema you understand is one you can evolve. A schema you've never read is a trap you walk into later. By the end of these 30 minutes, you'll be able to design, migrate, query, and connect a real database conversationally without memorizing SQL dialects, without fighting ORMs, without losing track of what your tables actually mean. Let's get into it. A schema is a promise. For example, this is what my data looks like and how it connects to everything else. Most developers either design schemas too early, locking in structure before they know what they actually need, or too late, retrofitting shape into a data mess, right? Vibe coding gives you a third path. Describe the data you want to work with, let the agent propose the schema, then read that proposal and decide if it matches your mental model. The description that works: name the things in your domain, describe how they relate, tell it the rules those relationships must follow. Here's an example for the to-do app from course 8. I have users, projects, and tasks. A user can have many projects, a project contains many tasks, and a task belongs to exactly one project. A task can be assigned to exactly one user. Tasks have a due date, a status, and a priority. That description is the schema spec: entities, users, projects, and tasks, relationships one to many in both directions, and then constraints. A task must belong to a project. The agent turns this into tables, foreign keys, indexes. Your job is to read what it purposes and push back anywhere it guessed wrong. Here's the mental shift: you're not writing create table statements, you're describing a domain. This is a higher level, more durable skill than writing SQL statements. Now, most apps don't talk to a database in raw SQL. They use ORM, object relational mappers. In plain English, an ORM lets your code talk to the database like it's talking to objects. Instead of select star from task where user ID equals 5, for example, you write something like user.tasks. The ORM translates it for you. This matters for vibe coding because when you describe your data domain, the agent will reach for an ORM automatically. Prism for JavaScript, SQL Alchemy for Python. The ORM is the layer between your description and the raw database. Your job is to tell the agent which ORM fits your stack, right? You do not need to configure it by hand. Just name it, use Prism with PostgreSQL, which is what we're going to use. The agent handles the rest. There's one thing to watch for: ORMs generate a lot of code. Review the generated models. Make sure the field names and types match the domain you describe. This is a plan review habit, the same as course 7. For example, if a generated model has a field called flag_1 or status underscore code underscore int, push back. Rename the field to something like priority, right? And make it an enum, low, medium, high, for example. That naming is yours to own. The agent handles the mechanics. Here's the trap that hurts teams and solo devs alike. You build a great schema, the app ships. 6 weeks after that, you figure out you need to add a column. You change the database by hand, and now production has something different from development and QA. And your teammate's machine has a fourth version. Migrations fix this. A migration is a version tracked change to your database structure. Apply it everywhere in the same order, and every environment stays in sync. How to describe a migration conversationally. Here's an example. The tasks table needs a new column: estimated underscore minutes, a positive integer, optional, defaults to null, add a migration for the new column. Here's what you get back: You get a migration file with a timestamp. The exact change, add column, set type, set default, a command to run it, something like npx prisma migrate dev. Here's a review checklist for any migration. Does it add what I described? Does it set the right type and the constraints? Is it reversible? Can I roll it back if something goes wrong? The rollback question really matters. Dropping a column with data in it is a one-way door. Ask the agent, is the migration safely reversible? If not, what do I lose? Let the agent warn you before you commit the change. Here's one more principle. Run. Never edit a migration file after it is run. If you need to change something, write a new migration. The agent knows this rule. Make sure you do as well. Performance is not a micro optimization you do at the end. It's a conversation you have while you're designing. The most common database slowdown, the missing index, right? Your app has 10,000 tasks and then you filter by user and status constantly, but there's no index on those two columns. Every query reads the whole table every time you query it. You don't need to know what an index is to ask for one, right? You just need to describe the usage. Here's an example. I'll frequently query tasks by user ID and status together, usually showing only incomplete tasks for a specific user. Make sure this is fast. The agent creates the right index. You verify that it makes sense in the migration. Okay, here are some examples of a few more performance conversations worth having. For example, are there any queries here that might be slow once the table has a million rows? Here's another example. This query loads a task and its project and its user all at once. Is that efficient with the ORM that we chose? Here's another example. What should I index on this table given these three common access patterns? Notice the pattern? You describe access patterns and scale. The agent recommends indexes, query shapes, and pagination strategies. Then you review and approve. Here's one thing to avoid. Do not let the agent prematurely optimize everything. Optimize this with no context leads to over-engineered queries. Instead, describe the real problem first. Okay, a database with the right schema but no data is hard to develop against, right? You can't test the UI. You cannot verify a query. You cannot see if the ORM is working as designed. Seed data solves this problem. Fake but realistic records, enough to build against. Here's what a good seed description looks like. For example, create seed data for the to-do app. 3 users, each with 2 projects, each project with 5 tasks in various states. Some complete, some overdue, some due today. Include at least one task assigned to a different user than the project owner. That is specific enough to be useful. Notice, you describe the shape of the data, not each individual row. The agent fills in realistic names, dates, and statuses. After running the seed, open up the user interface. Does it look right with real data? Does the overdue task show up styled differently, right? Does the assignment display the right user, for example? Seed data is not throwaway. Keep your seed data in your source control. It's documentation of your domain and your fastest way to reset to a clean state while developing. Now the part that makes database work really click in Vibe coding workflow, MCP, or Model Context Protocol. Here's a quick recap from Course 10. MCP is how Claude Code connects to the outside world, external services, tools, APIs, and databases. The best practice, keep around 4 active servers at a time when using Claude Code. There are MCP servers for major databases, PostgreSQL, MySQL, SQLite, and others. Once connected, Claude Code can run queries, import schema, and explore live data directly inside your session. Why this changes everything. Without an MCP connection, you describe the database and just hope. With an MCP connection, the agent can see the actual tables, run the query to verify, and show you real results. Setting it up is a one-time conversation. For example, add an MCP server for my local Postgres database. The connection string is in my local env file. Claude Code walks you through the configuration. Once it's connected, you're live. With a database MCP server configured, here are a few examples of what gets better immediately. For example, if you say, show me the 10 tasks most overdue right now, the agent queries your actual data. Here's another example. Is there any task with a null project ID? It checks directly, no guessing. Third example, that migration I just ran, did it apply correctly? It reads the schema and confirms everything. One important boundary. Give Claude Code read access initially, right? Only give write access once you're ready and you trust that the session is working the way you desire. Destructive queries are one bad prompt away. Review the query before running it always. This is MCP doing what it does best, grounding the agent in actual reality, not a description of your database, your actual database. All right, let's pull all of this together. We're going to evolve the To-Do app from Course 8 to have a proper database behind it. Step 1 is to describe the schema upgrade. Let's head over to our terminal and start up Claude Code. Okay, so here we are in our To-Do anti-gravity project from the previous course. What we're going to do first is we're going to actually build a Postgres server. Now, I'm going to build the Postgres server in Railway. That's the service that I use, but you don't have to use Railway. If you want to use Railway, you have to have at a minimum the hobby plan, which is $5 a month. But there's also a service that you can use, and I'll go right to it here. There's a service that you can use to actually spin up a cloud-based Postgres server on Neon, right? And so Neon is the Postgres backend designed for apps and agents. And in the development environment, you can spin up a free account, neon.com, spin up a free account or create a free account and create your new Postgres database, very similar to what you're going to see me do in Railway. Okay. I'm not using Neon, but I'm suggesting that because you don't have to pay, right? You can have a Postgres database that you can run with this course, this app for free at neon.com. Okay. All right. So I'm going to use Railway and I'm going to create a new database. And we're doing this because in order for Claude Code to actually build the new Postgres database that's going to support our To-Do app, we wanted to use an MCP server. So in order to create the MCP server, the first step is you need a database somewhere. You need Postgres running somewhere. So that's what we're going to do. We're going to choose database. We'll choose Postgres. And then Railway, much like Neon, will spin up a brand new Postgres database for you. And it literally takes seconds in order to do this, right? So our database, you can see it is fully online right now. What you'll need, whether you're using Neon or Railway, is the database URL, the public database URL. So I'm going to copy that. Now, the database public URL for Postgres contains very sensitive information. So I'm not going to show it on the screen. I'm not going to even show you the command to run the MCP server other than to show you the structure of the command itself, because I don't want you seeing passwords and actually server URLs and all of that in the course video here. However, this database URL is what you need. And I'm just going to click the copy command and you can see it's giving me a check mark. So I've copied it and I'm going to use that in the command to actually install the MCP server in Claude Code for the To-Do anti-gravity project, which is what we need to do. What I will do is show you what the command looks like, right? So how do you add the MCP Postgres database server to Claude Code? Here's how you do it, right? You use the Claude MCP add command and you give it a name. You can give it whatever name you like. I'm calling it Postgres-Railway dash MPX with a dash Y, and you use this package right here, which is the built-in Postgres MCP server. And then inside of double quotes, now when you copy the database public URL that you saw me copy, it's not going to come with double quotes. You need to enclose it in double quotes. this is what it's going to contain. It will contain the username for whatever platform you used, Railway, Neon, or some other platform. It will contain the password for your database. It will contain the public URL of your database. It will contain the port that your database is running on the vendor. And then it will contain the name of the database itself that your tables and entities and indexes and constraints are going to be stored in. Okay. And then some properties to tell it how to connect, to always use secure connections. Right. So when you run that command, your MCP server will then be configured. Okay. This entire command with your database public URL. I'm not going to run it again because I don't want to show secure information. Okay. But now that we have that running, now that we have our MCP server running, and if you want to know if your MCP server is up and running, you can type Claude MCP list. And if you type enter, it will show you whether your database server is up and running. I'm not going to do it because when it does that, it will actually display your username and password and database public URL on the screen when you do that. So just be aware of that. Okay. All right. So we're going to start up Claude. And then what we're going to do is give Claude a command to start building our database. And this is the command that we're going to give Claude. The To-Do app currently stores tasks in SQLite, which we did in a previous course. I want to move to a real database. Use Postgres for simplicity. I have users, projects, and tasks. A task must belong to a project. Tasks have a title, status, due date, and priority. Tasks also must be assigned to one user. Use the MCP server. That last sentence, use the MCP server, is letting Claude Code know, hey, listen, before you start to try to build this, look for our MCP server. Now, if you have not installed an MCP server and you try to run this command, you don't want to include that last sentence. Okay. So you might want to just take that out. And these files, of course, will be on the Google Drive for this course. Okay. Within this courses folder, course 29. All right, there we go. We're going to go ahead. Before we do that, we actually want to enter plan mode. So before we run the command, let's type /plan and then enter. Now, if you've already run your plan, you can press escape a couple of times to stop the plan or stop the command from running. Make sure you enter plan mode. We're doing this because what we want is we want to be able to review what Claude Code is going to do before it does it. Remember, we're creating a brand new database, and we want to make sure that that database is developed in a way that's ideal for us. Okay. We want to make sure it uses ORMs. We want to make sure it has constraints, table names, field names. We want to be able to review all of that before it creates it. Why? So that we don't have to go back and correct it. With that said, now that we're in plan mode, we can run our command. Okay, we can now see that Claude Code has come back and it has given us a plan. We can see persistence on the persistent line. This right here, we can see that what it's going to do is drop SQLite and JSON gone. The front end local storage offline cache stays. So we're still going to use that in terms of user experience and the front end app. It's telling us about status, timestamps, IDs. Here's foreign key deletes, migrations, task by project. So it has everything that it's going to do here. This is what you want to take your time and read, right? This is the plan. We haven't approved the plan yet. It's just telling us what it's going to do. And then it goes into telling us what type of tables and field names it's going to create. So here's where, if we wanted to, we could correct field names and indexes, right? If we wanted to add indexes, we could stop right here and give Claude Code feedback on the indexes that it's proposing to create. And you can see it has a project ID and status index with two fields here. We could propose updates here. This is why you want to review the plan, right? From our previous courses, we know that before we want to let our agent go ahead and build, let's review the plan first. We can also see the ORM models that it's going to create. It includes user, projects, and tasks. So there's 3 ORM models that it's going to create for us, creates the things. So we want to go ahead and approve the system after making sure that the ORM models are correct. Now that we know that, we can go ahead and run. So we'll run it. The next thing we're going to do is ask for some seed data. So the process will run, the entities will be created, but they're empty, right? They don't have any data in it because it's a brand new database. Okay, so the migration is finished, and now it's time to ask for our seed data. We're going to say create seed data to projects, 5 tasks each, a mix of statuses and due dates. Okay, and then we'll run that. Okay, so now that we have our seed data, we can take a look at the app. Here's the app. We can see that our new project section that, our plan told us it was going to create a new project section, allow us to navigate or toggle between projects. We can see that we can do that here. Got a couple of projects in there. We can also see that we have some tasks relative to this project, and some of the other projects have tasks as well. And we can see that we can navigate, we can switch between tasks. We can also add a new task here. And we can see that our tasks has users associated with it. So this completed task has Alex Rivera, and then these tasks have the default user, the task flow user. And so all of our changes are done, right? And it was successfully able to use our MCP server. That's the full loop. Schema, ORM, migration, seed data, live connection, start to finish in a single conversation. So what's your exercise? Well, design a schema for something you care about, right? Don't use the to-do app. Pick a domain that's real to you. A reading list, a recipe tracker, personal finance log, a work art journal. Describe it in plain language first. What are the entities? How do they relate? And what constraints must hold for the data to be valid? And then hand that description to Claude Code. Review the schema it proposes, push back on at least one thing, maybe a field name, a data type, or a missing constraint. Then ask it to generate seed data for you, and then run the migration and verify with a query. Share what you've described and what the agent got wrong in the Code to Vibe community on our website. The caught a mistake in the schema stories are the most useful ones for everybody. All right, let's lock in what you've learned today. You describe schemas in plain language, entities, relationships, and constraints. The agent proposes, and you review and own it. You worked with ORMs conversationally. Name the stack, describe the domain, review the generated models. You understood migrations, version changes, applied everywhere, always check reversibility before proceeding with a migration. You described access patterns for performance. Indexes come from usage descriptions, not premature optimization. Then you build realistic seed data. Shape over individual rows, keep it in source control. And you connected a live database via MCP, grounded the agent in actual data. Remember, 4 active MCP servers are the max. Here's where this leads. Your database is built and populated. The next question is, do you trust it? In course 30, we cover testing and quality assurance. We build the safety net that makes AI written code something you can actually ship with confidence. Unit tests, integration tests, end-to-end tests, and visual regression right inside of Anti-Gravity 2.0. See you in course 30.